So for these problems, the only thing that's tricky, the math is super duper easy. Here's Snell's law. All of these equations are on your equation sheet. I will also make sure to post the equation sheet just because of the paper issue. You may want to print that when you're at home. I'll also at least post up here on the document camera that big simple harmonic motion. Oh, thank you. That was very nice of her. That big like table, member for simple harmonic motion. So you don't have to memorize those. Those are not on the equation sheet, but I'll make sure that those are posted. Okay. So many of you probably still have your marking period equation sheet. Bring that in. Don't write a bunch of extra stuff on it. If you have, show me and I'll let you know if it's okay. All right. So for these, the only tricky thing is making sure that you match up the angle and the n value on the same side of the equation. So here, the angle and the n value, that's your unknown. So let's say that this side is air and this side is water. Thank you. So we've got 1 sine 40 equals 1.33 sine theta.
Where did I go?
Okay? And then you solve for theta, and you get about 30 degrees.
So does n represent like the density of the medium?
Yeah, it's like an optical density. It's the ratio between how fast light moves in the vacuum of space and how fast light moves in a medium. So notice there's no units. It's like mu. It's a ratio. Yeah.
So
it's a way to use simpler numbers instead of...
It has a higher n value. It goes from lower to higher, and it always tends towards it.
Yes, that's correct. Go ahead, Tom.
What mode should our calculators use?
Degrees. It's a good question. Yeah. Tommy asked a good question. Listen, guys, since this is happening tomorrow, does anybody have math tomorrow first hour? Yes. And my guess is you're going to be in radians in your math class, right? So I will try to remind you, but if I don't, because like as I get older and loonier and it's harder to access my short-term memory, the good news is I can still do this. I can still do the physics, but I forget things like, hey, put your calculator in degrees. Well, even those are not usually specific to a mode on your calculator. George? Yes. Yes. Let's talk about that. Yeah. Yeah. Yeah, good question. Is there a harder version of this? And the answer is yes.
What is it?
A more difficult version of Snell's law, listen please, is if you go the other way, from a slower to a faster medium, so like from water into air, okay? And water, we just found, has an n value of 1.33, air is 1. I'll give you 3 out of the 4. But let me show you why this is tricky. When you go from a slower to a faster medium, instead of bending toward the normal, it bends away from the normal. And it gets to a point where it will actually skim. Yeah, it'll skim that surface. It is called critical angle, yeah. So critical angle. And this is why it's tricky. I won't give you the exiting angle because you know it. It's not 0. It's 90. It's always to the normal. So if I ask the question, a light tries to escape from water into air, and it is at critical angle, then you know that that's 90. What happens if it's beyond critical angle?
It doesn't work. It goes back.
Yes, it goes back in. And where's my little Montreal box? There we go. You see, I said that with a fake French accent. That was great, wasn't it? Yeah, I speak fake French quite well.
Do it.
Montreal. And you just have to, like, always kind of, like, say it like you're smelling something bad. Like, Montreal.
American. I smell the ignorance in the hospital.
If you look at this, if you look through the water, you can see see the white liquid. So if you look from up top, right, everybody just close. But if you look off to the side, it's beyond critical angle, and what does the surface appear to be then? Silver, mirrored, right? So that means the light is being reflected, just like a mirror, just like a mirror. And so that's, the surface hasn't changed, it's the way you're viewing it, the angle, okay? So that's total internal reflection. That's total internal reflection.
Oh, so it's critical angle or more.
Right.
So it's still 90 degrees in the angle.
Well, what actually happens is that the light will come in, let's say it's bigger than critical, and then it'll just reflect and stay trapped. There's no math there, it's just concepts. But these are good review questions for multiple choice. So good job asking those tough questions. You will be glad that George asked about this. Okay? Could you solve this?
Yeah, because it's sine cubed, essentially.
Yeah, what does sine 90 equal?
1.
1. So solve for theta critical, blah, blah, blah. Answer is about 49 degrees. Okay?